Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to build a very simple app with Streamlit. So the app we're building is going to be using some technologies behind the scene. We're trying to use online machine learning or incremental machine learning to build a simple test classifier app. So let's see what we're building. So the app allows you to be able to predict if a test is hardware or software related. So let's check it out. So if I paste in a test like the code has a lot of bugs, right? If I go with this option, I click on predict, it's going to give me the prediction of that particular test there, right? So the data has been submitted. The original test was the code has a lot of bugs. The prediction is software. As everybody knows, this particular test is describing software, and we can also see the probability of the prediction, right? Software is 83%, hardware is 16%, and you can see a very simple diagram, right? I can also try something else. So let's say the drag, so the drive of the computer, right, is broken or something like that. So let's check it out. So it's going to give us hardware or software. So this is learning on the go, right? It is learning on the go. So I go back here and I check it out. This is hardware, as you can see, and it's giving us the prediction and then the prediction probability, and a very simple nice diagram, right? Now that is not the only aspect of the app. I can go to the sidebar of the app. If I go to the sidebar, I can check it out from the manage option and see all the various predictions that we have done within this app, right? So which is very simple. So we see all the various predictions. We have a lot of predictions here, right? Messages, the prediction, the probability of every one of them, the software probability, and then the hardware probability, and the post date, the time in which a post was made. Very simple. And you can also see a simple diagram that shows the probability as it goes over time. So this is how it goes in this particular graph. You can see from here. I said it's these are the dates, the time in which a post was made, and then the prediction as it goes. So it's trying to create a simple graph depicting the probabilities per the time, right? Something very simple, just to make it look fanciful. Then you can also check for all the software probability. So this is how it is. So this is the first one. This is per index, the first come first serve. So this is how it goes. So that it's going up, sometimes it goes down, sometimes it goes up, right? And for the hardware, we're also seeing the same thing, right? That is a simple app we built. Then finally, we can also check out the prediction distribution, right? So to know whether our data is working or not. This is software and then hardware. So there are more software within our model is able to predict more of softwares than hardware. That is something we're trying to build in this wonderful tutorial. So we'll be starting from scratch. So let's see the simple workflow that we're building with this wonderful app. So let me show you a simple picture of what we're building. So this is going to be the workflow. So the app is going to have two main pages. It's going to have our home page. Right, it's going to have our home page, which is going to consist of the place that we can enter our test using Streamlit forms. Then whatever is going to be entered here, we'll be training it with our model, right? So we just have a simple small amount of data which we use it to train within our app. Then we're going to use online machine learning or incremental machine learning, use a river or creamer, as we learned earlier on in the previous tutorial, to build and train a simple model which is going to be used to make a prediction on a test supplied. Then whatever result you're going to get, we are going to send the result, right, together with the prediction, the result, and probability into our storage database behind the scene using SQLite, and then we are going to view it in the next section of the app, the test and the prediction probability. That is a basic workflow of this simple app we're building. So let's see how to build this app from scratch. So I'll go back to my terminal. So this will be working on, and there's nothing else. So let's move into our Streamlit JLabs, and then you start writing some code, right? Right, so this is the workspace. Let's create a simple folder. I'm going to call it as, let's call it as test classifier river app, right? We're using incremental machine learning ML app. It's too big, but you get the point. Now go into my test classifier. This is the test classification, and there's nothing here, as you can see, right? So if I go back, let's create a simple file called app.py, and then we're going to open that particular file. So after opening, you're just going to open that particular app. So this is the one that is running, the current one that is running here, as you can see from this is the workflow. can see this is the one now it's running, right? So I'll just close this particular simple app, and then you design everything from scratch using the simple workflow that we have. So we're going to have just these two main sessions. So let's start from it. I'll go back again and let's open it. So I'm using Kali Linux, right? So you don't think it's Windows. Okay, so it's going to be Sublime to open that particular place. Perfect. And there's nothing here. We only have our app.py file. So let's set up our place and start writing some code. So I'll close the old one, and then we start writing some code. So let's close this one off. So you only have this one there, right? And let's start. So the most important thing that we need for this app is that we need to install Creamer or River. So it's going to be pip install. We will need to install Streamlit, right? In case you don't have Streamlit on the system, you also need to install Pandas, NumPy. You also need to install Seaborn, Matplotlib, and then you also need to install River, right? So that's what you want to be installed. Or you can install River or Creamer, and then finally you can also install Plotly. So these are the main things we'll be using for our app, right? Streamlit, Pandas, NumPy, Seaborn, Matplotlib, River, Creamer, and then Plotly. So that is what we're trying to, and then also Altair, right, to help us with our plot. Very simple. Now let's go back to our workspace. I'm going to open this one here, and I'm going to position my browser. So this is the old one, so we are closing this one. So let's open this one here. So let's start. So let's import our core packages. This is going to be our core packages as we already do. It's going to be import Streamlit as st, right? And then you'll be importing Pandas to Pandas as pd. So that is what we'll be doing, right? And then we just go straight away, and then this is going to be for our online ML packages. So we'll be using River to help us with that. So it's going to be from River, right, dot the particular model we'll be using. So we'll be using naive Bayes model. So naive Bayes model, right? Then I'm going to import multinomial NB, right? That's what we're trying to do, right, to help us with our stuff. Very simple. We also need to import our feature extraction. So from River dot feature extraction, we'll be using bag of words extraction, import my bag of words, right? You can also use tfidf in case you want, right? Any of them is going to work. These are the main things that we'll be using, right? And we also need to import a pipeline. It's going to be from river.compose. So in case you want to know more, you can just check the previous tutorial. Import pipeline. That is all, right? Very simple. So let's start writing the simple structure of the app. So according to the diagram that you are working on, we are going to have a home page and then a metrics page or a manage page, right? Okay, so let's go back again and then work on it. It's going to be my menu. Apologies for the noise you're hearing behind. Home, right? And then we're going to have our manage, and let's give our simple about page as we always do. Then we're going to have our simple choice. So st.sidebar.select select box. Now pass in my menu, which is going to be this menu, right? So just as we're going to have our first page. So if the choice is go to home, this is going to be our main page, right? st.subheader, our home page, right? Something very simple. Then do the same thing for the other one. Else if the choice is go to our manage, it's going to be st.subheader, our manage page. So this we are going to manage and then monitor result, right? Something like that. Then let's close it with st.subheader about, right? About the app. That is something very simple. Now after that, we just come down here and go with my if main. So I built a simple app to help us with that. So let's run this particular simple app we have done. Come back to my workspace here. So this is what you'll be using. It's going to be Streamlit run app.py, and I spelled it wrong. It's supposed to be Streamlit. There's no M here, right? And I'm going to run this particular app. So I'm going to use a default port and then your default browser to be able to run this particular app. So whilst it's opening, let's go back to the structure of the app. So the structure of the app is going to be with this option. We're going to have the home page, right, which we have done already. So we need to be able to find the means of working on the minimum data that we're working on, and then having our machine learning estimator, right, which we're using River, and then we'll make our prediction session. So it has finished by now. It's opening. So while it's opening, let me paste in the data, right? So this is the data that we used. go back here, and let's paste in the data here. But add the plotting libraries too, so we'll be also adding the plotting libraries too, like Seaborn and Matplotlib. So let me paste in together here. Right, perfect. So let's work on it. So this is going to be for our plotting, right? So we are using these ones to help us with our plots. So Matplotlib, Seaborn, and the rest. These things we have been doing over time, so you know this. And this is going to help us with our tracking of our time, right? Perfect. So let's also add some data to it. I'm going to add the data. So this is simple data. And as we learned earlier on in the online or incremental machine learning, the data that we are using is very simple, right? And it's going to take in as a tuple of tuples. So this is going to be our training data, right? It's going to be our training data. So that is the aspect for this particular place, our training data here, right? Now you have to be able to work on the machine learning aspect. So that is going to be here. Come down to the same map that we have here, right? So this is going to be our machine learning aspect, model building. We are building it on the go. We are using very small data to help us with that. So it's going to be in this option. As we learned earlier on, we're going to create a model using the pipeline, which is going to be my pipeline, which we imported above. So pipeline, right? Then we need to apply the stages of the model building for test classification. And as we learned earlier on, since it's test classification, we have to vectorize them, and we also have to be able to add our estimator to it. So let's pass in from our pipeline. I'm going to pass in our steps that I'm going to call as my vectorizer, which in this case we are using bag of voice, right? So let's use a bag of voice, and then let's make sure that everything is converted to lowercase false, right? Everything is lowercase, right? So lowercase true, lowercase false, right? You want to set everything to lowercase. You can make it true. Any of them is going to work. And after that, this entire stuff here is our vectorizer to convert our test into vectors, right? Perfect. Then after that, I'm just going to move on to the next one, which is going to be our next step, which is going to be our estimator. So let's go to naive Bayes model. Now pass in my naive Bayes multinomial, right? Multinomial NB. And we can also give it, let's leave it like that without any parameter. Very simple. So this is going to be our simple pipeline that we have built. Let me expand it. All right. And then with online machine learning, we learn on the go. So S and Y in my data, I'm going to learn on the go. So the model is going to be built, which is going to be model dot learn one. We are using river, so we just go with learn one, not fit one, because this is river. Now passing my S, now passing my Y. So this is going to learn on the go, right? Very simple. I'll save it. Now the model has been built. Now let's create a place to receive the test from the user, right? So we're using Streamlit forms to help us with that. It's going to be with st.forms. Now passing the particular name of the form. So let's give the name of the form as key is going to be, let's go to ML form, right? Something like that. ML form would be a very nice name for a package. Okay, so let's move on and create a simple column. So let's go to let's call it home, yeah, column 1 and column 2, which is going to be st.beta columns. I'll pass in my column, so 2 and then 1, just to make it beautiful. And I'm just going to with column 1. I want to do something. I want you to specify the message which I want, which is going to be the message st.test area. Let's use test area. Now pass in my test. So this is going to be the test that the person wants to type there. So let's go to message. Perfect. That is all. Then you need to specify a submit button. So submit message button, which is going to be my st.form submit button. And let's give it a particular prediction. So let's give the label. So label is going to be predict, right? That's going to be the first one. So with column 2, I want to also specify something very simple. So let's write something simple. st.write. Let's say online incremental learning, right? ML, something like that. Then I can just specify some simple message st.write. So predict test as hardware, software, or hardware related, right? That is the main idea behind what you're trying to build. So let's see what you have built so far. I'll come down here. Let's go with always rerun. Hopefully there are no mistakes. Perfect. So everything is working as expected. So we have our test here that you can pass in a test. So this is so cool, right? If I click on this predict, it's going to now work on it. Perfect. So let's display the result. So we have gotten one place to display the result. So this entire stuff is a form, right? Perfect. Now outside this particular form, I'm just going to come up and say that if the person click on the form, so if submit message, right, for the form, right, if we submit a message for the form, I want you to do something. So I want you to get the prediction, which is going to be my model dot predict 1, right, as we learned earlier on. Now pass in my message. That's going to be the prediction. Perfect. Then we also need to get a prediction probability. So prediction probability, which is going to be my prediction proba. So my same thing with it. So model dot predict proba 1. No, yeah, predict proba 1. Remember that this is online machine learning, right? That is incremental machine learning, passing the same message. This is going to give us our result. Perfect. That is all, right? And then we also want to get the maximum probability. So this is going to be my product probability, because this one returns double values. So let's go with my max predict proba, right, dot values, right, dot values. So let's check what you have done so far, so that you know that we are on track. So let's go to st dot success. Tell the personal data submitted, right? And let's display the result. So I want to display the result, so I'm going to create another column. So let's call this one as result column 1, result column 2, right? Let's call it as result column 1, result column 2, right? Then I'm going to specify the same thing, st dot beta columns. I'll pass in my 2, just 2. And let's display the result. So the result is going to be with result column 1 display. We are going to be displaying the test. Too much of the coding. Let's see what you have done so far. Let's display the test itself. So it's going to be st.info original test, right? So this is going to be the st.write the message the person applied. Perfect. Then I also want to specify not just a message, but I also want to specify the prediction. Let's call it st.success is going to be the prediction, right, of the test. Then I'll just go st.write the prediction. So let's save it and see where we are. So it's giving us an error because it says that syntax error, right? That is why sometimes when you're around writing the code, you should be, we forgot this, there's no, yeah, so it's going to run. Perfect. So let's check it out. So this is so cool. Or let's say this code is legit, right? So if I click on predict, this is software related, right? So data submitted, original test, this code is legit. You see that we have our software. This is learning on the go, right? This is learning on the go. Perfect. Now since we have one aspect, we also need to be sure that we create another place to display the probability and then the other one. So I'll go back to the app here, and then we work on the displaying of the probability. So it's going to be this, the same thing we did here. So we're going to create another option. So let's work on the other one. So with result column 2, right, we want to also bring the other one. So info probability. This is going to be our probability for the prediction, right? You want to show the user the prediction, right, the probability of that particular prediction. So we just go with something simple. There are several ways you can do that, but let's first of all write it out. So st.write then predict proba, right, referring to this particular predict proba that we had here. So let's save it and see what you have done. So it is learning on the go, the same test. Click on it. So that's giving us our results, software, and you see that the probability, right? Very nice. So the other alternative is that we can also visualize it. So let's do a simple plot of this. It's going to be a plot of the probability, right? I can't spell probability, probability. So in case you have any question or contribution, you can just put it in the comment section below. Okay, and I hope everybody can hear me. Okay, let's check it out. So let's create a simple data frame. But this is a dictionary, right? So this is a dictionary. So since there's a dictionary, we can actually use it to create a simple data frame. So pd.data frame, and I'll pass in these ones as my dictionary. So let's give it my label, right? Which is going to be my prediction probability dot keys, right? So these things dot keys. This one, software and hardware, is going to be our label, right? That's going to be our label, right? And then this one is going to be the actual probability, so probability, and this one is going to be the predict probability dot values, right? So this is going to create a simple data frame, and if I check it out, so st dot data frame, let's pass in my df probability. Let's check it out. Let's predict again, giving us our results as expected. So now just giving us our result. So this is going to be the label, and this is going to be what we want, right? Very simple. You can actually transpose it if you want. Transpose the entire stuff to get the result. But let's move on, and then let's plot a figure. We're plotting a figure. This is going to be our visualization. We are using Altair, so we have to import Altair above, which we have already imported. So import Altair as ALT. Then I'll just come down here, and then I'll create my figure. So figure is going to be my Altair dot chart. I'll pass in my data frame. Then I'm going to say that, okay, this is the data frame I want. I want you to make a mark bar, right? And then I want you to encode it and put in this particular value. So S is going to be my label, the label column here we are seeing, and then Y is going to be my values column. It's going to be my probability column, right? That is all. That's how to plot it. So it's going to plot that particular plot inside the figure. Then to be able to see the plot, we can use st.altair chart to help us with that. Right, perfect. So Altair chart, then I pass in my figure, the one I want to plot. I also use container with, right, you set that one to true. Perfect. So let's see what we have done so far. So I'll go back, use the same thing. This code is legit. I'll click on this predict, then it's going to give us all the results. You see, you have our original test probability, we have the data frame, and we see that we have our result, right, which is very nice. I can expand this one, and then I can see it working as expected. Perfect. So out of the box with Streamlit, we can build something simple, right? So now let's go back and take off the data frame. We don't need it again. We only need a plot. We have finished building the first part of the app, right? The home page with the training, the online estimator, making the prediction. Now let's move on to the other part of the app, in which we'll be storing the predictions into a database, so that it's not just an app that predicts, but it's a data collecting system that collects data from the user, store them, and we can use it further to do a normal batch machine learning, right, instead of online machine learning. So that is the basic understanding behind what you are trying to do. So I'll just go back again, and then we will continue. Okay, so that is something simple. So let's move on to the next part of the app, which is going to be the manage option, right? So there's nothing here, so let's go back again, and let's first of all add the result. So we'll be adding the result that you are getting here. So to make our work easy, to save us time, I'll just copy the code for the data, and it's for storage in a database, right? So we're using simple SQLite to help us with that. You can use any particular package that you have to help you with this particular option. So let's call it as my, so import SQLite, right? We're using SQLite 3. I'm going to create a connection to the database, which I've not created. SQLite, it's SQLite 3, not 3, not 2. There's no SQL 2, right? Dot connect. Let's make a connection to my database. So let's give it a name as data.db, right? Then I'm going to create a cursor, which is going to be used to do the connection or execution. Perfect. That is all, right? So let's create a table. I'm going to create functions for the table for SQL, right? All the SQL stuff. So let's create a simple table. So def.create table, and this is a simple table you are creating. You're going to that, okay, I want to create a table, so c.execute. I'll paste the code later on to save us time. So it's going to be that create table if not exist. If the table does not exist, I want you to create a particular table. Then let's call the table prediction table, right? That is the table. The table is going to have some fields, right? So it's going to have the message that the person supply. It's going to have the probability or the prediction. Then also going to have the probability, right? Something very simple. And then let's also add a post date, right, for that particular date that it was posted, something like that. Now this is what we'll be receiving, right? A message, the prediction, probability, and then post date. Now the message is a test type, the prediction is also going to be a test, but the probability, as you can see from the results you are getting here, right, from the previous part of the app, let's go back and check it out. If I go back to not the manage but to the home page, and then we see what we are doing, let's hide this one out, right? We see what you are doing. If I go back and I make the prediction, let's call it as I built an API, right? So this is going to be software. If I check this one out, as you can see, it gave us as a dictionary, right? The result that came was a dictionary. So we cannot store a dictionary into a database like that, right? There's a different way. So we want to be doing that. You just pick only the software column and pick the hardware column and then store them separately, right, into our database. So I'll come back here and then let's uncomment this one out, right? So what we're doing that, we'll just be storing the probability, right? This is going to be number, right? And a post date is also going to be date. Perfect, that is correct, but we want to add some 2 ones to it. So this is going to be the software probability, so software proba, and then hardware proba, hardware proba. That's what you're trying to put there, right? Very simple. And then this is going to be integer, right? And the other one is also going to be integer, right? Or can make it test anyhow you want it to be, right? That is the basic understanding. So let's make it as test, and this one also as, no, let's make it as number. It's not a test, it's a number, it's a float, right? But let's make it number, right? Perfect. That is something simple. So we have built a simple function to create our table, right? And the next one is that we're going to be creating another one to add the data. So def add data, which will be passing the data that we want to add. So be passing in the message, the prediction here, and then you also pass in the probability, and you pass in the software probability, the hardware probability, and then you're going to pass in the post date, right? That's a simple function you're creating. So let's do that. We go and c.execute, then we write a simple SQL function which is going to be insert into the prediction table that we have these particular stuff, right? So that is what we do. I'll copy the code to save us time. So I just copy, we are setting into that particular place this thing here. I'll set into that place these values, and then we have question mark. So 1 2 7, it's going to be 1 2 3 4 5 6, right? So 1 2 3 4 5 6. Yeah, perfect. That is all that we'll be doing, and I have to also paste it back again. The values, right? That is a simple function we are creating to help us with that task, and then we will commit it, right? Something simple. Now let's, in case I want to view it, I can just go back again and create a simple function to view it. View data, then I'm just going to use the normal select to help us get our data, right? So c dot c.execute, use select all. So select all, right? Select all from the prediction table. That is a simple function you're creating, right? And now from here, we can just bring out our results. So data. So everything is going to be stored inside data. So c.fetch all. And then I'll pass in, I'll return that particular data. So this is for the database aspect of the app, right? In which we are trying to follow this pattern. So we are finished with this aspect. We are finished with this place. We are now trying to store the data inside our storage, and then later we view it. So I'll go back again to this place that we have, and let's test it out, right? So we are just creating a table, and we are adding the data there, right? And then we are going to view it. That is all. We are not going to be deleting it, right? Okay, so let's initialize the table anytime you run the app. So create table function is going to be initialized here, and then in case we want to add the data, we will add the data after we have getting the result. So I want to add the data here. So let's add the data at this particular place, right? So add data. I'm going to pass in my prediction, pass in the message first, as we saw earlier on, pass in the prediction, pass in the probability, and then pass in the software, right? So in order to get that one, I can just go back again and do this option. So we have my prediction. We have this predict prober here, right? So with this predict prober, then I'll pass in the first one, which is going to be my software, right? And the next one is going to be predict prober. The next one is going to be the hardware, right? And then we need to get the post date. So that is the next one, the post date. So let's work on the post date here. I can come down here and create my post date, which is going to be my daytime. We are using datetime to help us with that. The time the person clicked on it, right? So date time dot now. The reason we are adding a post date is that it's to help us to be able to track our model, right? And the results you are getting. Okay, very simple. So that is all. Hopefully you understand. Perfect. So in case you have any question or contribution, you can just put in the comment section below. So this is where the data is going to be at, right? So let's go just add data to database, right? So that is it. We're going to add the data to the database. Perfect. Here. And now we can now just go back again to the manage option and then see what you can do here. So just as we created a view option, we can also get everything out. So let's go to my new data, right? Or let's go to stored data. Store data that is coming from that place. I'm just going to specify that, okay, use a function view data to get it. So let's call it as view all data, right? We are viewing all the data, not just viewing some of the data. We want to view all the data, right? This is returning a list. Now I can just move on and say that, okay, create a new data frame, and this new data is going to be my pd.data frame. I'm passing the new data or the stored data. So if I save it and let's bring it out, st.data frame, my new data frame. Let's check it out at the manage session. I don't know whether my audio is okay. Hope my audio is okay. So in case you have any idea of videos you want us to do, or you want us to learn something, you can let us, or can specify it in the comment section below. So I'll go back here to the manage session. And voila, you see that we have our result here, right? So the text is here, but it's not having the column header. So let's specify the column header there. So I'll just go back again and then specify the column header. So using the same thing that we did above to get the column number header. So columns, which is going to be these ones. So to save us time, I'll go back to this place here, copy this, right? And then convert this one into a string, right? So this, all of them is going to be strings. So let me paste it to save us time. Perfect, right? So if I go back to it and I check it again, so now we have it. So the message, the prediction, the probability, right? And then the software prediction, which is the same thing. The highest is the one that is going to be stored here. We have the hardware probability, and we have the date that it was posted. Let's add in another data. So I'll go back to the home and let's put in something different. So let's call that Streamlit apps are so smart, right? Something like that. So click on this. Hopefully this is going to be a software, but it can also be a hardware anyway. It's hardware. I don't know why it's given us as hardware, but anyway, it has been stored. So this prediction that we made, everything has been stored in the backend and inside our database. You can see that the data is here together with the time, right? Very simple. Now let's move on and do some plots of this so that it becomes easy for the manager, right? The admin people. I'll go back again, and I'm going to be doing some simple plot in this particular place. So let's convert. In order for us to plot it, well, we had a date column here. As you can see, there is a date column. So let's convert this one to the proper date so that we can plot it, right? I'll go back and now let's convert that one well. So this is going to be my new df, convert the post date to date column. So pd dot to date time, yeah, converting to pandas date time, then I'll pass in that particular column. So new post date, right, so that we can actually plot it. Perfect. That is all. Now let's plot it. So for us to plot, let's use a simple try except. We try except, so we'll be passing in the code, right? So in case there is no code, there's nothing inside the database, I want you to bring st.warning or info no data to plot, right? Perfect. And it's going to be the pass, so that in case there is no data, that's what it's going to be shown there, right? Perfect. So that is a simple function we have created. Now let's work on this and check it out. So I'm going to create an option for the plot, right? So let's pass this one and then create this one. So let's go C alter C, just C, right? Alter, and I'm going to create my chart for the entire stuff. Chart, just as we did above. Chart, which is going to take my new data frame. Then this is going to take a mark. Let's use a mark line, right, instead of a mark bar. Then I'm going to pass in my data. Let's encode. What am I passing? I want to pass in the S. This is going to be the post date, and then the Y is going to be the probability, right? So we want to be checking the probability column only. Can't spell probability. Very simple. Now let's plot it out. So in case I want to plot it, it's going to be my st.alter chart, passing my C, and let's see. Just running it perfectly, so that it's giving us our plot, right? You can see that we have the post date here, right? And then you have these things. And the one nice thing with alter chart is that you can actually, in case this is the entire date, right? In case you also want to not just see this date, but you want to change the time, you can specify it here. In case you want to see only the minute, and so automatically going to convert it because this is already daytime. So alter will understand the plot and then just plot only the minute. So this is a minute, right? So that in case you want to be very precise, you can use a minute option. In case you want to be, you can use hours, you can use seconds as you wish, right? So that is the basic understanding. So by changing this one here, we can get everything converted to minutes because this has been already converted to daytime. That is the basic understanding behind it. But let's use the normal. So let me copy this one here to save us so that it can be reference for future people. So this is going to be for, let's say, for a minute, and then this is going to be the normal. Let's go with the normal. You're not adding anything there. So let's hide this one out, hide the first one, and use the second one, right? Perfect. That is something simple. Now let's plot not just the prediction, right, and then the probability. I also want to plot for the software and for the hardware. That is where the other one comes out. So I'll do the same thing we did above here. I'll copy the same thing here because it's going to be the same code, and I'll just paste it here. So this option here, right, this, let's call it as C proof for the post date and probability, which I've already done, right? You can also come back again and say, let's say C software prober, right, something like that. Then this is going to be only for the software part of the app, not the entire stuff. I'll pass in that particular data here. Let's go as my software proper. Then let's reset it. So dot reset index. Perfect, right? We are using mark line. We are just creating the post. So at this particular place we can use a post date. So if I check it out, let's see whether the plot is showing. st.author c software proper. Hopefully it's going to work. So no data to plot, right? It's telling us no data to plot because I think it's giving us an error. So let's take off this. You will fix it later. I'm taking off this one. And let's take it out. Okay, so it's giving us an error, right? So put this encoding field is specified without a type, right? So we have to make sure that we fix it. That's why it's just giving us that particular error. So I'll come to this place. We have reset the index, so I'm going to change it from post date to index, right? Let's call that one as what? Index instead of post date. That's first come, first save. And let's check it out. It's going to come perfectly well. It's loading. No data to plot. Let's fix it again. So in case you have any question or contribution, you can just put inside the comment section below. And please don't forget to subscribe and then share and like also. It's giving us an error with the encoding, so let's fix it. Sometimes the best way to fix an error is to read the error. Probability encoding for a specified without a type. The type cannot be inferred because it does not match any column in the data. Okay, so that means that we have to fix some things there. So I have to just change this one. So this is the software proper and this is probability, right? That's why it's giving us an error. We have to change this one to the respective field. So I can make this one as index and then I'll make this one as my software proper, right? Because we're making a mistake. Perfect, and now you can see that it's working, right? So you can see the prediction. So this is first come, first serve, first, second, third, based on the index, based on the data set that you have. You can also twist it, but I prefer this one, right? You can also twist it the other way around using the time. Any of them is still going to work if you wish. So in case you also want to use the same code here, it's still going to work. Let's do the same thing for the hardware. So this is for the software, for the hardware. I'll change this one. I'll change this one. Hardware, right? And now you can also plot them out. But I prefer to create a simple column to make our work easy. So let's call it as my C1 and then C2 st.beta. I like Streamlit. It makes it very easy, right? Perfect. And like I can just put in 2 here. Perfect. Right, I said that with C1 I want you to create this with C1 dot st C1 st dot beta expander. Let's add a beta expander to it. This is going to be the software probability, right? Then I can just bring that particular plot here. So st.author. So let's copy it. It's here already. Copy this and paste it here, right? Then I'll do the same thing for the other one. So I'll copy this one for this, so that we have it there. C2, this is going to be hardware, and this is going to be hardware. So let's check what we have done. So we are going to have it's giving us an error here because we brought this question mark in the column here. Sometimes I make that mistake because of the width, right? Perfect. We're going to be having 2 plots here. Perfect, and then perfect. So the reason is not very clear. It's not very clear is because we are not using use column width. So I have to go back and specify that. Okay, that's one nice thing about Streamlit. You can see from here how this plot is being shown, right? If I plot it, it is shifting beyond the column width, right? So in order for me to use the column width of this particular place, I just have to come down here and specify that, okay, use column width use column weight and set that one to true. That is all. Streamlit makes it very easy to build stuff. Wow, right? So our app has been built. If I check this one out, we have it there, right? Very simple. And then we also have the main one here, right? Now let's move on to the final one, which is going to be the probability. So we also want to check not just the test, we also want to check distribution of the prediction, right? So we can come down here. That's going to be the next one. Outside of this place, with st.beta expander, I want to call it as my prediction distribution, right? Or value count, something for short. Then I'll just specify that one. So to do that, just go use Seaborn to help us with that. So I'll call that my figure 2. So plt.figure. You can use Seaborn, you can use Alter, any of them is going to work. Then from here I'll call that sns.count plot. I'll pass in my new data frame, passing the probability. That's what you're trying to get. The data is going to be my new data frame. So you can use this option here. This is going to work, or you can just go straight away without this. So S. This is another way you can also plot it. Right, any of them is going to work. Now I can just go with my st.py plot. I'll pass in my figure 2. So let's check it out. So it's taking some time. Perfect. Let's check it out. Voila. Right. So you have seen how to build our simple app, and you can see the results down here. Right. Very simple. Very cool. So to recap, we have seen how to build a simple app using River ML. That is an online incremental machine learning tool like scikit-learn, but it's for online incremental data processing. We built a homepage that had a small amount of data that we used to train to build our model. We made some predictions. We are storing the predictions inside the database, and then we are displaying the result there. So you have seen how to display the result as test and the prediction probability inside our simple app that you have built here. Very simple. So the more data we add in, the more the chart is going to change. So if I come back and I add another one here, so it's not just for the prediction, but also trying to collect the data, right? That is the basic understanding, right? So let's say that, say the software has bugs, right? Let's predict. This can be software, but it can also be hardware, right? This is software, correct? We got the prediction, the probability. I can also change it and put something here, like say the computer is good, right? Something like that. Let's check. This is going to be a hardware. This is also software, right? But you can see how the prediction is, right? So as it's keep on adding data, yeah, you are getting more data, and then this is online, right? So it's difficult for you to maintain. So you are not just doing the online, we are also storing the data, right? You can see how it is changing over time. This was the one prediction here, right? And this is coming down here, right? So different probabilities you are trying to check. Sometimes it's better, sometimes it's bad. And you can check the software probability, the first come first serve, right? This was the first one, and then you see the difference, right? You can make it better. This is just for proof of concept or something, just for fun. And then this is the probability. I don't know where this one came from. I don't know where this one came from. Okay, so that is something very simple. So thank you for watching this tutorial. In case you have any question or contribution, you can just put inside the comment section below. So to recap, this is what we built. We built a simple app from scratch. We imported our packages, Streamlit, Matplotlib, and then Seaborn and Alter. We had our daytime to monitor the daytime. For the online packages, we created this simple one to help us with that, right? To help, this is the pipeline to build our model, and then the vectorizers and estimators. And then we had a small training data. We built our pipeline to put the data on, and then we have a place to store our result into a database, and this was the main pages that received the data, right? So thank you for watching. See you in the next session. Stay blessed. Bye.